Hello, this is Hanjun Cho, and this is Physics 2211 Lab 4 Oscillations. Here are the table of contents that I will be going over today. The purpose of this lab is to analyze the motion of mass oscillating on a spring by using two different models and to determine if the model follows the energy principle. One of them is video recorded, and one of them is a computational model using GlowScript. A preview of the result is that the system's total energy remains zero throughout the experiment, therefore satisfies the energy principle. Here are some fundamental principles used in this lab, including Newton's second law, conservation of mechanical energy, or energy principle. Well, energy principle here derives the conservation of mechanical energy, like when there's no external work done on the system, the initial total energy is equal to the final total energy. And then we have the kinetic energy formula, string potential formula, gravitational potential energy formula, and also the velocity and position update formula derived from Newton's second law. Here's a video analysis, and here's some initial conditions that I got from the video analysis. So since this dropped from rest, the initial velocity would be 0, and initial position is found by taking the first data point of the x and y position, and then the stress string length and object's mass is given in the file section of Canvas in the video. Some initial conditions and assumptions are the following. The period is approximated by taking the average of each time interval when spring is at most stretch position. The string constant is calculated by using the period formula, which is 2 pi times the square root of mass divided by string constant, since we already calculated the approximate period. Relaxed position by using Newton's second law, which spring force is equal to gravitational force, and we also assume that no other work is being done on the system of the block, the spring, and the earth. Here are the computational model. So here are some initial conditions we got earlier, some constants, and all the formulas we need to use. And during the while loop, we constantly update the energy so we can graph it. And then we use a velocity and position update, and then we also use the change of energy to keep everything updated and graphed. So both graphs overlap at the start but deviates after a few oscillations, and of course due to human error, my y position of the spring is very different from the computational model's graph. Computational model follows energy principle, while the video analysis does not, because of the assumptions we made, which means that in reality there are indeed external work being done on the system, such as force of drag. Here are some possible errors, including human input errors, calculation errors, and assumptions. What does it mean? So, energy principle is satisfied because changing energy remains 0 during and after the code calculation, meaning there are no external work done on the system. However, that's not the case in the video analysis because, as I said in the last slide, in real life, the systems are not isolated, meaning that there will be some type of external work done on the system. For the second question, the estimated period using x value is 1.61 second, and estimated period using y values is 1.5, meaning that choosing which axis to work with when estimating periods can produce different result in other calculations also, such as when calculating spring constant.